My name is Bram, and in this video I will talk a bit more about a tool I made in Unity. It's a multi-layered audio container. It's a tool made to replace the native audio container in Unity, while also having still the play one-shot function. So you can fire and forget your sounds more easily. So how does it work? The base layer we have is an audio layer, which takes an array of clips. You have a vector to decide min and max volume, and it has an element name. It returns a random clip. I added functionality that for now it keeps in account repetition limits. So the half of your array, it will look for a different clip than it played last time before it returns the other clip. Then this is the main part of the tool, is your multi-layer audio base. I use generics throughout this whole system to make it more clear what layer something is, but it will be more clear in a second. So this takes an array of layers and has multiple functionality. This is a tool I made. It started with just display multi-layer on source, which made sure that of every array you had, it played one clip at the same time. It was introduced in a course for us for making gunshots. For example, you have a layer of clicks, transients, your body, a thumb layer, and every time the sound plays in games, it picks one of those elements, and that way you have an insane amount of variations without having that much of memory in your game. But I thought it was a cool thing, so I tried to improve upon the functionality of it. And then I made a container element, which you can select what container to play, and it then behaves like a random audio container, but with the play one-shot function. So it's easy for footsteps, for example. You can push all the sounds through, and it will never overwrite the previous one. This is what I had, and I noticed in the terms of maintainability, it was quite hard because you have container names stacking. So I then made the audio enums class. So this is, for example, this is the project we did for the Xbox Game Camp, the 2-day game jam. So this had to go fast. I have an enum for the two characters, and then in here I just say what type of sounds the character will use. And then I make a multi-layer audio for the little guy. Back then his didn't have a name yet, now he's Beep. So, and then this takes this enum. Hence why I use an enum here, so it knows what it is. It's more clear when we go into the editor. So you can now see I have my multi-layer objects. If I want to make one, in Space Cadet was the name back then still, I can say I want a multi-layer audio for the little guy, and then it will show you the element names from that enum that I used. Why? Because if you have different ones for different characters, I have one for music, I have one for UI, I have one for everything that's an environment. So it gives way more clarity if you do it like that, for now at least. That's what I found. So you can see the MLA for this character looks like this. If you have a pitch min max, which would control the pitch for the entire object. You have your elements, so all of these are one audio layer, which contains your audio clips. You can choose your min-max volume, and also the most important one is the element name, which is the name that's used when called upon in code. So in this example, there's the attach element, and then of course you give your attached sound effects to it. And this is how I build up the small character quite fast in 2 days. The fact that you have a min-max volume also makes sure that you can mix separate sound effects as well. For example, in here, the footsteps were very loud, so I could say, okay, every time you play it, it's minimum 0.3, max volume should be 0.5. So this is very handy tool to have some detail mixing in terms of what sound containers you want louder or quieter as well. So how does it work on the actual prefab and in code? So every code call is inside a piggyback script, so it takes up the multi-layer audio object that you assign to that specific object and which source you use. Why? Because sometimes you want sound effects to loop. For example, it has a scanner which starts, it loops, and it has an end sound, but this is based on gameplay input, which is also something that the tool supports. Make it fade in, it loops. When the player releases the button, it fades out again. So you need a different source for that one. You have your classic one-shot audio source, and then for footsteps. Why? Because it's nice to have more control, because if you add more materials, you might have a separate multi-layer container only for your footsteps as well. And then you store in stone footsteps, wood footsteps, grass, all the types you want. So in code itself, if you click it open, you go to the piggyback, you give it in here. This is where you pass it. And then even if you're not really specialized in audio, you can call in here your multi-layer audio container. You say, okay, play my container element. In what source do you want it and which one? And this is the only thing you have to do in code. So it's quite clear. If something's not working or the timing is wrong, you have to find one line, which takes care of having your random audio container fully functioning, playing with the limit repetitions and so on and so on. So this is how the tool works. Like I said, it started in a class built for the gunshot with the layer audio source. Then I tried to make it more maintainable, scalable, and centralized, which has its own pros and cons, obviously, with making a container element. And now for the beep and bumper game, I had to add functionality for the fade in, the fact that it could loop and fade out without having any clicks. So it's a tool that I'm quite proud of now, but I can see it's a very good exercise to know how to make it maintainable. What if there's a different project, or if it's a bigger project? What functionality does it need? Because for now, whenever I have a new project, I still need to change some stuff around so it works for that specific project. So the ultimate goal is to just have this tool implemented inside of a project. It's ready to go, ready to use, and it gives all the functionality you could wish for an in-engine implementation.